Hello everyone, welcome to KnowledgeIndia once again. In this particular session, we are going to talk about some of the advanced AWS features which you can go ahead and use and build a strong IAM model for your enterprise. The kind of things which we are going to talk about are permissions boundary, AWS SSO, even usage of cloud formation, Stacksets, etc. Right, so we'll try to cover these topics with a scenario. We will see a visual, we'll also see a demo that how you can go ahead and implement permissions boundary in your environment. AWS SSO is now renamed to IAM Identity Center, so wherever we use that term, you should be aware. So what's the scenario which we are looking at? There is a company called FMW Corp. It's a big automobile giant. They had a security audit recently of their cloud environment. And here are the key problems that need to be addressed from security perspective. The first one is that there are so many IAM users in every AWS account. Now this company has got like 50 plus AWS accounts, of course, and they have many IAM users in every AWS account. Many of these are not even recently used. And also it is difficult to track that who is using which IAM user. So that's the problem number one. Problem number two, IAM users and roles often have more than the required permissions. So when the auditor looked at the policies which these IAM users or roles have, the auditor found a lot of star scenarios, which means, for example, a lot of EC2 star, IAM star, DynamoDB star, and things like that. A lot of stars in the IAM permission. So most of the times, more than required permissions. And the third problem here is that the BAU team, the business as usual, or the operations team members, they are from a vendor organization, from a third-party organization. And many of these team members, they have unlimited access, which means they have got IAM star, right? So the question is, what if a particular team member goes rogue? If a particular team member has got IAM star, it means that person can go ahead and do whatever that person wants, which means the person can go ahead and basically change the permissions for any other user or role. Also, person can go ahead and create other new users and roles, etc. So these are three problems or key findings, I would say. Now, as we discussed, the team structure at FMW is in such a way that, of course, FMW, it's a multinational organization, and they utilize many vendor organizations to manage different tasks. So for example, they trust a particular third-party company to handle their cloud operations, build, etc. Okay, so that's the situation. Now, what we are going to do is try and analyze all the three problem statements which are given, and we will try to figure out that how can you solve it in this enterprise, right? What steps we need to take and how do we actually break this problem. So the first one is about IAM users. Here is the statement. Why is there a problem with IAM users? First of all, if IAM users are there, is there any problem? Is there any disadvantage related to that? You have to think about it, right? So the problem with IAM users is that IAM users have got long-term credentials, right? Which means, let's say for an IAM user, there is a username and password, or there's an access key, ID and secret access key. Now, these things do not expire on their own, right? So that means you need to have a process to rotate or change these credentials. So that's an extra maintenance task for you, right? And because these are long-term credentials, the chances of person exposing this somewhere increases, right? Because these are long-term credentials. So that's the disadvantage. So do we really need IAM users? That's the question, right? Can we reduce it? Can we reduce or can we get rid of IAM users? Answer is yes. If we do things right, we can get rid of all the IAM users, for that matter, from an AWS account. We might keep a couple of them, but we should be able to largely reduce them and we can try and bring them to zero. So let's try and analyze this step by step. The first thing is, for what purpose are these IAM users getting used? So there may be certain IAM users which are there for human usage. Let's say there are different people, of course, working in the organization, and they make use of these IAM users, right? So what can you do, right? So these IAM users or these humans are probably, making use of management console, click ops, basically logging into the management console and doing clicks and achieving their targets, or they might be running CLI commands, etc., right? So what you could do is go ahead and implement SSO, right? And make sure that all these human users now make use of SSO, right? Basically, they will be given a user in SSO, right? And that way, they'll not have any long-term credentials. And when you set up SSO, you will make use of your organization's identity store. Let's say your organization's Azure Active Directory, for example. You will make use of that with AWS SSO. And what will happen? Because of that, a person in your organization, a person in your company would log in with FMW corporate credentials, and using that authentication, the person will come and get into AWS accounts. The person need not remember and will not have any other IAM user or any other IAM username and password, right? So that way, all the IAM users which are there for human usage, all of that can be removed, right? All of that can be removed. That's the point number 2. So, and with those SSO users, right, there's no need of credential rotation because there are no long-term credentials, isn't it? What you can also do is, as an additional step, go ahead and create a rule in your AWS accounts which will trigger a notification, right? You can set up CloudWatch event rule or event bridge rule, and this will trigger a notification every time an IAM user gets created, right? And you can send this notification to a core team which further analyzes that why somebody has created an IAM user. You can also go ahead and log this information into a database, right? Just write a Lambda function and put this entry into a database and use that database to kind of showcase that when and all different IAM users got created. It will also help you to to kind of investigate things. So human usage you have handled. Next thing is, there may be certain IAM users which are there for usage by apps. Let's say there's an application, right? There's an application which is making use of a certain IAM user credentials. Let's say a certain IAM user's access key ID and secret access key is being used by a particular application. So what can you do in that case? So whenever you look at such scenarios, what happens is there are two things. First is, many of the times you will see that behind the name of an app or within an application team, actually there is a person who uses the credentials sometimes to probably upload some file to S3 or to do some AWS related activity, and for that purpose the person uses the access key ID and secret access key, right? So actually the name is that the application is using it, but it is actually a manual usage by a human. So if it is that type of usage, you can push that user also to an SSO user, right? Because using AWS SSO, you can get CLI credentials, which will be short term, but you can get CLI credentials and anybody can go ahead and just configure it in the AWS CLI and then execute CLI commands. If, on the other hand, in real, an application is actually making use of the IAM user credentials, then you should ask the question that why are you not using an IAM role? So you should push the application team to go ahead and make use of IAM role. Now, if the application is hosted somewhere on AWS, surely IAM role can be used. There can be a last scenario that yes, the credentials are being used by an application, but the application is not hosted on AWS or it is hosted maybe somewhere else. and hence it is not possible to use to make use of an IAM role, and hence an IAM user is really required. So you should treat only that condition as an exception, and you should develop a process in your organization to come and review such exceptions regularly. Okay, so that's how you will handle the first problem, which is for IAM users. Now, if you go ahead and follow this path, you should be able to reduce the number of IAM users to a very small number. You should be able to bring it down considerably. You might be able to bring it down to even 0. All right. The next one is about more than required permissions. Why does that happen? In any enterprise, if you go ahead and see, this happens because a thorough profiling exercise is generally skipped, right? So organizations start using cloud and they actually miss on figuring out that how many teams are there, which team is supposed to do what and not supposed to do what, and hence what type of permissions should be given to a particular team. So number one is go ahead and do a thorough profiling of the IAM actions which are required by different teams. It could be a whiteboard exercise, it could be an Excel based exercise. First do that. Now, based on what actions are required to be done by a particular team, that analysis then translates to the actual IAM policies which will be given or which will be attached to that particular team or will be given to that particular group of users. Now, how will you achieve it really? You need to hire people who can write custom IAM policies for any given requirement. You can hire or you can go ahead and train, but it is really important that you have people who are able to write custom IAM policies. Unfortunately, a lot of people actually do not pay attention to this part and hence are not able to write it very well. It's very important for your organization to be able to write fine-grained IAM policies. It's very important. The next thing is IAM policies should never be attached directly to users, right? Whether we are talking about an IAM user or an SSO based user. You should never attach the policies directly to a user. Rather, it should be always attached to groups. Why? Because in real world, think about this. If you have done the profiling properly, which is point number one, if you have done that profiling properly, then what would happen is that every team which is there on the ground, that will correspond to a group on the AWS side, right? So as you figure out that a particular team does ABC actions, then you go ahead and basically give ABC permissions to the respective group. Basically, teams transform to groups in the system, right? If you are actually going ahead and giving policies directly to a user, that means there are exceptions in your model. You are just giving more or less permissions to certain individuals. So make sure that you always give permissions only to groups. Okay, and you don't give permissions to users directly. So this will make sure that your JML process will be very strong. Joiners, movers, leavers process will be very strong. When a person joins a team, the person will be added to a group. When person leaves the team, person will be removed from the group, right? So that's how you should operate. Now, when you set up AWS SSO, you have this option that you can select on the Azure AD side that what groups or users you want to push towards AWS SSO. Now, it's highly recommended that you push AD groups. You select AD groups and push that towards SSO and don't push individual users. Otherwise, you will be violating the point number 4, which is written above, right? So if you push only the groups, then what you can do on the AWS SSO side, you can select the respective group and allocate permissions to that group. Number 6 is implement a process of reviewing the IAM policies at regular intervals. Like at what intervals those policies, custom policies which were written got changed. You need to keep a track of it and you need to review it regularly. You can go ahead and develop a dashboard for that matter, which showcases the dates when the policies got modified for the core teams at least, because that will give you an idea that how well your profiling was done and whether the policies which got changed were really required or whether something happened without the without the knowledge of core people, all such things actually happen on the ground. So go ahead and implement this process in a in a strong way. The last one here is, even after doing all of this, you might still end up with a few services with star, in the policies. Basically, what I'm saying is there might still be certain policies where you will have like all permissions for a particular service, but that's okay. It can be handled, and that's what we will see in the next step. Point number 3, if you remember, the problem was that BAU team has unlimited permissions, right? Basically, this findings, what it states is that, see, FMW as an organization is trusting this third party because that third party vendor is actually running their operations and cloud. So because of that, they have given all the permissions to this third party vendor organization. Now the auditor is saying, what if a member of this vendor organization goes rogue? Means that person is not happy and that person decides to one day go ahead and delete all the critical resources of FMW. What will you do, right? So first of all, why is this third party organization having all the highest permission? It's because this is the team which is the operations team, and hence that team manages all the key servers, whether you talk about backup servers, enterprise backup servers, AD servers, any other shared tooling servers, all of that. And next is they also create the IAM resources as and when requested. Hence, it looks right for that small core team to have IAM star, right? Because that's the team, which picks up the request for creating any IAM user or IAM role, right? So of course they need to have IAM star, then only they can create IAM user or role. But that is problematic, isn't it? Because if they have IAM star, just think about the possibilities, what all they can do. They can very well go ahead and just create a user for a few minutes, give highest permission to that particular user, and then using that particular user, newly created user, they can go ahead and delete stuff, and after that delete the logs as well, and then delete that user also, right? All such things are possible. So how do you handle this situation, right? This is where IAM permissions boundary comes in. There is a detailed video which I have done. I highly recommend you to watch that if you haven't watched it already. You'll find the link in the description. Permissions boundary, it's a very powerful feature. What you can do is, of course, you can use CloudFormation Stacksets, which I will show you in the demo, how you can use CloudFormation Stacksets to go ahead and provision permissions boundary across multiple accounts, right? So you can do it in one shot, you can implement it or provision it across multiple AWS accounts. IAM permissions boundary is nothing but just an IAM policy. But what you do is you use it to kind of draw a maximum boundary outside. I'll just explain it to you in a minute. What you will do is you will go ahead and allocate the BAU team IAM star, but then you will restrict the possibilities what this particular team can do via permissions boundary. Within the permissions boundary, you will go ahead and deny the non-negotiables. So every organization has got certain key resources, right? For example, your backup server, certain S3 buckets which have got your very important artifacts, some backup snapshots, network components, right? So such things are non-negotiables. You cannot have those resources modified or deleted, isn't it? So you will be able to go ahead and deny any actions on such non-negotiable resources using permissions boundary. Remember that you can attach only one permissions boundary with any user. So what does that mean? It means that whatever you want to achieve, you will have to write it in one IAM policy, because with any IAM user or IAM role, you can attach only one policy, one IAM policy as the permissions boundary. Let me try to explain you that how the permissions boundary works with a diagram, and then I'll show you a demo, okay, so that you become clear with this. So let's say there's an IAM user. This user's name is John, and this user started work, and based on the type of activities this user is doing, this user is given certain permissions. Let's say EC2 star, RD star, great, no problem, everything is going fine. Then this user gets something more, S3 star, DynamoDB star, still okay, right? Person is doing the job. Now this person has now joined the BAU team, which I was talking to earlier. And now this person has been given IAM star. Now this is where the problem starts. As soon as this person gets IAM star, this person actually now has power to go ahead and do whatever this fellow wants, right? So what we'll do is, to rectify the situation, what we'll do is we will go ahead and draw a boundary around it using IAM permissions boundary. So what will we do in this boundary? And in the next step, I'll show you a demo so you will understand. I'll show you a permissions boundary policy as well. But at a broad level, what are those things which you will implement in this permissions boundary, right? So number one is deny the modification or deletion of critical resources. Number two is allow only those services which are whitelisted in your organization. See, AWS has 200 plus services. Now you can go ahead and implement using permissions boundary such a restriction that maybe your organization has allowed the usage or has whitelisted 50 services or 40 AWS services only are getting used. So you can go ahead and implement it using permissions boundary that you will whitelist only those 40 services. And if the user tries to go and use any other service which is not whitelisted, the person will just get error, right? It won't work. Third thing is enforce that a new IAM user or role cannot be created without attaching the permissions boundary policy. So you will also enforce this restriction that any new IAM user or role gets created only when the permissions boundary policy is added. If this BAU person tries to create a new IAM user without attaching the permissions boundary policy, the user creation will fail or the role creation will fail. Number 4 is permissions boundary cannot be deleted for an existing IAM user or role. This is what also very important. While the user or IAM role is getting created, at that time you have to enforce that permissions boundary policy should be specified. Also, you have to ensure once the user or role is created, after that, the permissions boundary policy cannot be deleted after the creation of user or role, right? Suppose the user is created today. After that, it's a separate IAM action using which the permissions boundary policy can be removed or can be deleted. So even that has to be denied. The fifth one here is, and the last one here is, permissions boundary policy itself cannot be modified or deleted. That also you'll have to enforce, that nobody should be able to go ahead and delete or modify the permissions boundary policy itself, right? These are, I think, the important things which you will implement within your permissions boundary policy. Now, good thing is using CloudFormation Stacksets, you can go ahead and implement or provision this permissions boundary policy across multiple accounts. So in an enterprise where you have got, let's say, 30, 40, 50 accounts, it becomes really easy for you to go ahead and implement it. What we will do next is I'll show you a demo where I'm gonna show you a permissions boundary policy which I've written, and we will go ahead and provision it in multiple AWS accounts within my organization. So I'll pick up a particular OU, and within that OU, all the AWS accounts which are there, in those AWS accounts, this permissions boundary policy will get created. And post that, I will go ahead and create an IAM user as well. And for that IAM user, this permissions boundary policy will be attached. And after that, we will see the whole thing in action. Okay. So I hope you are able to follow me till this point. Now let me show you the policies first. You can see here that there's a CloudFormation template here. And using this CloudFormation template, I'm creating an IAM policy. You can see the resource type is IAM managed policy. And I'm naming it as the DND permission boundary. And within this, of course, there are many statements. You can see first statement and then second statement and so on. And in this, I want to quickly show you that what all different things I am doing. So first thing which I'm writing is basically a deny statement. And this deny is written for IAM create user and IAM create role, right? And also put user permission boundary. Basically, this action is used to attach a permission boundary with a user or with a role. So for all these three things, I am putting a condition that if IAM permission boundary for this particular attribute, this value is not specified, then it should fail, right? I've written a condition that, you see, string not like I'm using. So if this is not if this particular thing is not specified, then the these actions will fail. And you can see here I'm making use of star. So basically this policy would get implemented in multiple AWS accounts. Now in all the different AWS accounts, the permission boundary policy which will get created, I'll show you when it gets created in different AWS accounts, just this account ID will differ, right? Rest of the things will remain same. So for the account ID, I'm making use of star and it works fine. The next thing I'm doing is I'm denying the deletion of certain roles or removal of policies from certain roles. These are organization related roles. If you have implemented organization in your account, you will also see similar type of roles in your member accounts. So I'm making sure that nobody is able to touch these roles. Another important one is this. Here, if you see, I'm writing a deny statement in which I'm making sure that my permission boundary itself cannot be modified or cannot be deleted, right? This policy itself cannot be modified or deleted. After that, I'm also writing deny statement for two actions. IAM delete user permissions boundary and delete role permission boundary, which means nobody would be able to remove the permission boundary from an IAM user or from an IAM role. So that's why this deny is written. And at last, you can see I've written certain allow. This is allow for certain services like EC2, CloudWatch, IAM, S3, logs, etc., etc. There are a couple of services. The point is, all the things which I allow here, those are the maximum allowed things, right? So for example, you can think this is my whitelisting. So I'm whitelisting here, let's say whatever, there are some 12 or 15 services. So doesn't matter a particular user has got what permissions, person will be able to operate only on these 10-15 services. For example, if you look at this thing, there is no Redshift permissions here, right? There is no Redshift permissions here. Now, if I go ahead and create a user called John, and for user John, if I give Redshift of full access as well, and after that I attach this permissions boundary, user John won't be able to do anything in Redshift because the ultimate whitelisting is there in the permissions boundary, and here Redshift is not whitelisted. So this is the important concept. I've explained this in very detail in my permissions boundary video. So anyway, this is my permissions boundary. So what I'll do is I'll go ahead and create this now. I'll also quickly show you this user creation. Here, this is another template. In using this, I'm actually creating an IAM user. I'm giving multiple policies to this user like EC2 full access, read-only access, IAM full access. And for permissions boundary attribute, I am giving the the ARN of the permission boundary, which I would have created. Of course, I'll go ahead and first create permission boundary and then I'll create the IAM user. I'm making use of this global cloud formation variable, AWS account ID to kind of replace the correct account ID in, while this gets executed in every AWS account, right? So that's simple. So I'm going to create a permission boundary and then I'm going to create a user. So I'm logged in here in my master account, right? Master account or management account, and I'm there in the CloudFormation service. I'll go to Stacksets and I'm going to create a stack set. And I will choose the option service managed permissions, right? So I don't need to worry about giving any IAM role. Basically, if I go with service managed permissions, because I'm operating from the management account, I can just go ahead and create anything in basically any AWS account. So I'm just selecting that. Of course, we should use it with responsibility. So I'll go ahead and say upload a template. I'll select the template here. Okay, so template is selected. I'll say next. We'll give it some name. Next. And here I need to say that where do I want to deploy this. So as I told you, I'll go ahead and deploy it in one of my OUs. So here I've got a couple of OUs. What I'm going to do is I'll pick, there is a particular OU where I've got some 5-6 accounts. So I'll pick this OU's OU ID and I'll put it here. After that, okay, I don't need to filter anything more. I'll go ahead and select Northern Virginia region. I'll just increase this. I don't want it to fail because of any reason. So we'll just go ahead and acknowledge and say submit. So now it will go ahead and create this permissions boundary policy across all the accounts in that particular OU. So you can see 1, 2, 3, 4, 5, 6. So there are 6 accounts and the creation has just started. So it will take maybe 2-3 minutes for this to get created. All right, so you can see now that the creation is done in all the 6 accounts. If I go here to the operations, you can see it says succeeded. Great. I'll come back here to Stacksets and I'll create another stack set. This time I'm gonna select the other template which is there for user creation, of course. So I selected it. We'll say next. I'm gonna give the name here, user creation. Say next. And again, I'll deploy it in the same organizational unit. Choose the region and then go ahead 6 and yep, I'll acknowledge this and submit. Now it should go ahead and create the user as well. So while we are waiting for this to get created, just a summary, what we are doing at this point is we are actually creating 6 different IAM users. Basically, the name of the IAM user is John. It has the same password, but of course, like we are creating this user in all of these 6 AWS accounts, right? Now, for all of these users, John, or for if we pick up any of these one account, the user John has the permissions boundary attached. So which means all the restriction which I talked about, all of those restrictions would be applicable on user John. So I will, as this gets created, I will log in using that particular user John and I will show it to you. All right, so you can see here that the user creation is also done now. And if I go to here, you should see succeeded, right? Good. So with that, both of our stack sets are created, which means the permissions boundary is there, the user is created. So what I will do now is I will go ahead and get into one of these accounts and I will show you that how the user John actually is working. This is the account ID. Name of the user is John. So I need to now go ahead and change it. All right, so password is updated. You can see that I'm logged in here in this particular AWS account as this IAM user John. Okay, you can see it at the top right. I'll go ahead and click on IAM and this is the IAM user John. If I click on this user, you can see the details. This user has got these 6 IAM policies and IAM full access is also there. Good. And you can see this permissions boundary is attached, which is DND permission boundary. That's the thing. If I want, I can I can go ahead and show it to you really. Let me just open policies in a new tab and just show you. So if I go here and here is the DND permission boundary, right? So you can see, as I told you about the ARN, here it is given. Just of course the account ID will change here in all the different accounts except this account ID. Rest of the things will remain same in the ARN. Whatever I had specified, that complete policy is available here. Great. So for this particular user John, now though this user John has IAM full access, you can also see that this permission boundary policy is attached. So which means now if this user tries to create another user and goes ahead and creates it without attaching the permission boundary, that should fail. So let's go ahead and try to do that. So as this user John will try to create a new user. So I'm pressing on add user, and I'll go ahead and try to say a new user called Lucy, and I'm just saying that let Lucy have this programmatic access. I'm gonna give administrator access, the biggest possible or the maximum privilege possible access to this person Lucy, but I'm not selecting any permissions boundary. So I'll go ahead without selecting permissions boundary. Go to the last step, you can see permissions boundary is not selected. I'll press create user, and you can see it fails. It would not allow John to create this user. Even if John tries, that let's try to fool the system by, of course, just attaching some policy, not the correct one, but rather by attaching any other policy for that matter. Let me just pick up something and just go to next. I can remove this and then say create user. Once again it fails, right? Unless until the correct policy is selected as the permissions boundary, it won't work, which is this one. So if this is selected, next, let me remove this, go next, and now you can see in the permissions boundary this is coming. So we'll go ahead and say create user, and now this user got created. So Lucy is created now. So even when now this particular person Lucy or this user Lucy which got created has got admin access, which means literally star of all the services, right? But because this permissions boundary policy is attached, Lucy cannot go ahead and do things which are not allowed in this, right? And that's the beauty. Doesn't matter what all policy gets added, you have drawn the outer boundary and nobody can cross that boundary. So think about this in your enterprise setup. You can go ahead and set it up in this manner, and you will ensure that though you are allowing a team or a certain group of members to have IAM permissions, but they can never go ahead and do those things which you don't want them to do, which means basically things which we talked here, they can never go ahead and do these things which are mentioned on the right side, right? And that way you save your organization from damages. Now, before we go ahead and wrap it up, I hope you understood this and you are able to understand that how can we go ahead and implement it. I'll request you to go ahead and do it on your end. And if you have watched it till this point, please like the video and of course share it with someone. The last point is, and very important for you to think, whatever restrictions we talked about, right? Whatever restrictions I showed you just now, why can't we go ahead and do those restrictions using service control policy? That's also a method. We can go ahead and implement restrictions using service control policy as well. So why can't we go ahead and do that using SCP? What is the design consideration there? On what basis are we saying that we should do it using permissions boundary? Okay, pause the video, think about it for a couple of minutes and then move ahead. Why are we not doing it using service control policy? Let's try and understand. Service control policy can be implemented only from the master account or from the management account. Now, if I have to implement these things or modify these things, I'll have to give access to more number of people to be able to go ahead and do these things. And because this is possible only from the master or management account, it's like opening up that account to more people to, so that they are able to change this or modify this regularly. Whereas if I'm doing it via permissions boundary, all I need to do is create CloudFormation Stacksets. And the good thing now is AWS allows you to delegate this CloudFormation administrator thing from the master account to some other account. Right now it is possible. So that's a really, really good thing. Here is what I'm trying to tell you. So if you see here, you can delegate, you can make some other AWS account in your organization, which is not the master account or management account, you can delegate that account as the administrator. And that way, in order to update this permission boundary using CloudFormation Stacksets, you don't need to let people get into your master account or management account. That's the first thing. Second is, with SCP is very stringent. With SCP, when it is enforced, it restricts all the IAM identities within an AWS account, which means whether it is an IAM user, IAM role, even the root user, all the identities within that account will face that restriction. This can lead to a lockout situation, right? Because let's say there is a particular member AWS account, you would want that, yes, most of the users shouldn't be able to delete stuff, right? Or certain critical things. But there has to be a small team, a very core team in your organization whom you trust ultimately. And they should be able to modify or delete or edit such things, because sometimes you would go ahead and do it, right? So if you implement the restriction using SCP, then that won't be possible, because that restriction will be enforced on automatically on all the IAM identities or on all the IAM entities in that particular AWS account. But with permissions boundary, you can play it in such a way that only those IAM identities would be restricted which have permissions boundary policy attached to them, right? So you'll not get stuck in a lockout situation, right? That summarizes it for us. You should use permissions boundary in those scenarios where you want to implement the restriction for X number of entities or for X number of users, right? Not for all the users and role, right? If the restriction is of such a type which you want to enforce on all the users and on all the roles and even the root user in a particular AWS account, such type of restrictions are there, then SCP is the right thing to use. But if you do not want to enforce that restriction on all the IAM users and roles, then permissions boundary is the right thing to go ahead and use. I hope you learned from this video. This is a really important stuff, and you should think about enforcing these things in your organization. If you would like to discuss further on this and ask something, feel free to comment. And if you like this thing, learn from this video, go ahead and share it in your circle and let us know what should we cover in the next one. If you are interested in learning more, we have a lot more such practical videos which you can go ahead and check on our YouTube channel. There are a lot of playlists. You will be able to learn from that. And till we meet again, thank you for your time. See you. Bye-bye.